The purpose of this video is to explain a really important concept, the concept of a random variable. And we're going to do a very simple experiment. We're going to flip a coin 2 times. And here we see the sample space, the set of all possible outcomes that could occur when we do that experiment. So we get a head, then a tail, head, then a head, etc. So what is a random variable? Formally, we can define a random variable as a real value function whose domain is a sample space, but that's kind of hard to understand. In simple English, a random variable is a translation or a mapping. It takes the outcome of this experiment and translates or maps it into a number. And in this case, the number, the random variable, is the count of the number of heads. So we have a head, then a tail, we get a 1. If we have a head, then we get is a 2. So another way to think about a random variable is that if we look at these numbers here, it's the set of all possible values of the number of heads. So one of the things that's really important is that we distinguish the idea of the random variable, which is the set of all possible values of count of the number of heads, and the number of heads that we get when we actually do the experiment. And that's where this idea of randomness comes in, is that if I were to do the experiment today, I might get a 1. If you were to do the experiment today, or I were to do the experiment tomorrow, we could get a value of 2. But again, critical to distinguish the set of all possible outcomes from the one that actually occurs when we do the experiment. So with that brief introduction, I want to move on to figure 4 in your notes, which is the table that's shown here. So this is a result of a very simple experiment where we had 3 red and 1 white marble in a sack, and we draw 5 marbles with replacement. And the random variable in this case is the number of red marbles. Okay. So what I want to think about is this idea of PY. And this is the probability distribution. And what it does is it takes, look at PY, it takes some value of Y. It could be a 0, a 1, a 2, 5. Takes the number of red marbles as input and translates that into the probability of getting that number of red marbles once the experiment is actually conducted. So let's look at P1. So what we're doing here is we've got this function, PY. We substitute the value 1 for Y, and what we want is the probability of getting 1 red marble if we draw 5 marbles from a sack with 3 red and 1 white marble. We do that sampling by replacement. And so the answer to this is, in a general sense, the binomial distribution, P of Y is going to be equal to n choose Y, pi to the Y, 1 minus P to the n minus Y. So in this case, P of 1 is going to be 5 choose 1, 0.75 to the 1, 0.25 raised to the power of 4, and that turns out to be 0.015. So again, this is the probability distribution. Input a particular value of the random variable, and what comes out is that that particular value will be the value obtained, the realized value, once the experiment is actually done. So one way to think about this is say, okay, let's look at it in a general sense. Py is equal to the probability that y is equal to y. And this may look really confusing, but it's actually very important. And maybe to help a bit, let's put in some actual values. Let's consider P of y equals the probability that y is equal to 1, and that's equal to, as we've just calculated, 0.015. So what's going on here is that uppercase Y is the random variable. It's the set of all possible values of number of red marbles that might have been realized. Lowercase y, this lowercase y, this value of 1, is the actual number of red marbles. And so the key thing that I want to emphasize is to make a distinction between capital Y, the set of all possible outcomes that could occur when the experiment is run, and lowercase y, which is the single actual observed value you get when you do the experiment.